Algebra class. Sorry I can't be with you today, but that's all right. We're going to do a lesson anyway. So you should have notes. If you don't have notes, push pause, ask the guest teacher for some notes because I did print them out and you should have them ready to go as you watch the video. So today we are going to be learning about solving equations with variables on both sides. By the way, I'm recording this after school on Thursday, so if there are interruptions, I apologize, but somebody might come to the door, there might be announcements or whatever, but we'll deal with it. So anyway, here we go. Objective 1, use properties of equality to solve linear equations with a variable on both sides. And objective 2, identify whether linear equations have one solution, infinitely many solutions, or no solutions. Hopefully, you will remember most of this from pre-algebra, if you've had pre-algebra, because we do this stuff in pre-algebra. So it should feel very familiar. I hope you will recognize most of it. Warm-up is not too involved today. Some friends want to see a movie that is showing at 2 different theaters in town. They plan to share 3 tubs of popcorn during the movie and construct arguments. Which movie theater should the friends choose? I'll give you a second to think about that. And you should be thinking about the notion that it's going to depend on how many friends there are. And if there are a bunch of friends, then they want the cheaper theater. And if there's only 1 or 2 friends, then they're probably okay with the more expensive theater and the cheaper popcorn. So there are several ways that you can set up to solve this for part B. We're going to set up an equation here. I'm going to solve that in just a second. You could make a table. You could just kind of brain power it. But we're going to do an equation because that's what we do in algebra class. I'm going to move this up here where I have a little more room. And get my chair here where I can sit right. Okay. We have the first theater that has ticket. Theater A is $14.50 per person, which we don't know how many people, plus 3 tubs of popcorn at $5.75 each. And we want that to equal Theater B, which is $13 per person, and 3 tubs of popcorn for $6.75 each. So all we gotta do is solve it now. 1450x plus 17.25 equals 13x plus 20.25. Now we just need to balance the equation, so I want all of my variables to one side. I'm going to take I'm going to subtract 13x from this side, and I'm going to subtract 17.25 from this side. In pre-algebra, I would always do this in 2 steps. But in algebra, I like to combine steps to get them done in, as efficiently as possible. So hopefully I'm not losing any of you here. So 14.5x minus 13x is 1.5x, and 20.25 minus 17.25 is 3. So 1.5x equals 3, divided by 1.5x, or 1.5 rather, and x equals 2. So that x equals 2 means that if 2 people go to the movies, then the tickets, it doesn't matter which one they go to, the tickets and popcorn will cost the same. If 1 person goes and eats 3 tubs of popcorn by himself, he should go to Theater A. If 3 or more people go to share those 3 tubs of popcorn, then they should go to Theater B. That's the kind of thing we want to be able to do with solving equations with variables on both sides. So we're going to jump right into it, work our way through all of the examples on the page, and see if we can get out of here. All right, what is the value of x in the equation shown? Remember that we are still trying to solve equations efficiently whenever possible. So if we can skip steps where we distribute, we will. We can't always do that. Sometimes we do need to distribute, and this is one of those cases where distributing is best. So 3x plus 4x is 7x. I still have a minus 10. And here I need to distribute a negative 2, so it is negative 2x. Negative 2 times negative 4 is a positive 8. And then I have plus 9 at the end. Now I need to gather like terms onto the same side, so I'm going to add 2x here. Add 2x here. I'm going to add 10 here, which means add 10 over here. So these 10s cancel. I would have 7x plus 2x is 9x. Those cancel, so I'd have 8 plus 9 plus 10 is 27. Last step, divide by 9, so x is 3. Somewhere along the way, they're going to ask you or want to know how to check your solution, and of course you would just check your solution by putting your answer, 3, back into your original equation for x. So wherever you see an x, you would substitute a 3 and multiply it out and check your solution to see that it works. All right. Of course, you can pause at any time or go back if you need, if I'm going too fast. I'm trying not to go too fast, but there you go. Question B, what is the value of n in the equation shown? Well, this is one where we don't have to distribute. We can, first we can do this. We can get rid of this 7 here so that it's not in our way. And 1/2 x, or 1/2 rather, times n minus 4 equals negative 2n plus 13. And I'm going to multiply everything times 2 to get rid of the fraction. So that is n minus 4 here equals, I'm multiplying by 2, so I need to do negative 4n plus 26. I multiplied both of these terms by 2. There you go. Now I can balance the equation, so add 4n to both sides. I always start by looking at the variable and choosing one of the two variables to work with. I either need to do something with this n or something with this term, and adding is always better than subtracting. So I'm going to add 4n, but then I need to do plus 4 here and plus 4 here. So 1n plus 4n is 5n. Those two cancel. These two cancel, and then 26 plus 4 would be 30. Divide by 5, n is 6. I don't like that color, I'm gonna switch. All right. Just a couple more examples to work through of finding solutions with variables on both sides. Here we do want to go ahead and distribute. So distribute the 100, it'd be 100 z minus 20 equals negative 50 z minus 8. So I can either subtract 100z or add 50z. I'm going to add 50. I'd rather add than subtract. So add 50z. And then I need to add 20. Add 20. So 100 plus 50 is 150z. z. That cancels and that cancels, and negative 8 plus 20 would be 12. Last step, we're going to divide by 150. And z equals 0.08. All right, once again, this one's got a fraction in it, so we usually try to multiply by something to get rid of our fraction, but in this case, I could multiply 16 and a 24 both by this fraction and still end up with whole numbers. So in this case, distributing the fraction really doesn't hurt me at all and actually gets me a step closer to being to having a solution. So in this case, I'm going to go ahead and distribute the fraction. 5/8 of 16 is 10d, and 5/8 of 24 would be 15. And then I can distribute on the right side. 6 times d is 6d. 6 times negative 1 is minus 6. Add a 1. So now I can either need to subtract 10d or subtract 6d. So I would rather subtract a small number than a big number. So minus 6d, which means I need to do minus 15. So 10 minus 6 is 4d. Those cancel. These cancel. And then negative 6 plus 1 minus 15 comes out to be a total of negative 20. Divide by 4. So d equals negative 5. All right, so that's quite a few examples, 4 or 5 examples of working through different scenarios with equations with variables on both sides. We got to be pros at solving equations. If this part here is a struggle for you, that's okay. We just got to make it not be a struggle, because if we can't solve equations in algebra, it is going to be a really long and really tough year. So this stuff right here is like the basic thing that we need to be able to do in this class. So we got to get this, we got to get it down. All right, moving along. So understanding equations with infinitely many and with no solutions. So there are 2 types of equations. We need to learn to recognize them, and the quicker you can recognize them, the easier things will be. We don't want to have to get all the way down to the very end of an equation before we see it and recognize that it's going to be infinite solutions or no solutions. So we're going to work on that skill through this section. So first thing I want to do is distribute the 2. So 4x plus 6 equals, when I distribute the 2, 2 times 2x is 4x, and then 2 times 3 is 6. So at this point, you should notice that both sides of the equation are identical, and that's an important word, the word identical. But let's look and see what happens. If I subtract 6 and end up with 4x equals 4x, and then divide by 4, then I end up with x equals x. And when you end up with this, it's called an identity. They're going to use that term throughout throughout your assignment, throughout the chapter. If we end up with an identity, that means that it doesn't matter what the identity of x is. It doesn't matter what number we put in for x. The equation is always going to work no matter what number x is. So this is a case of infinitely many solutions. So an infinite number of values can be put in for x. All right, and we can recognize it at this step here. When I have the same variable term and the same constant term on both sides of the equation, then I recognize that it's an identity, that it is infinitely many solutions. All right, let's try another one. So what is the value of x in this equation? 6x minus 5 equals 2 times 3x plus 4. So nothing to do here. 6x minus 5, distribute the 2. 2 times 3x is 6x, and then 2 times 4 is plus 8. So here, this is the step where we should recognize that we have no solution. And the reason we have no solution is, look what happens if we try to solve it. Subtract 6x, subtract 6x. Well, the x's are gone now, and all I have left, on the left side of the equation I have a negative 5, and on the right side of the equation I have a positive 8. And that is not true. That doesn't work. It's never going to work. It doesn't matter what value I put in for x, any number that you can think of, it's never going to work. So this is a no solution equation. No solution. All right. So we need to learn to recognize those. So let's try a couple here. We've got question A, 2A, t minus 27 equals negative 27, negative of the quantity 27 minus t. So we need to distribute that negative symbol. The negative symbol distributes just like a number would, so negative 27 and a negative together would be a plus t. So here we have an identity. It's identical because we have a positive t on both sides, and we have a negative 27 on both sides. All right, so this one is an identity or infinite solutions. Identity. Okay. All right, let's go ahead and work out this next one. We'll just distribute. 16 times 4 is 40, nope. 16 times 4 is 64. And 16 times 3 is 48m. And 96 times a negative m divided by 2 would be a negative 48m. And then 96 times 1 is plus 96. So this one comes out to be, we've got a negative 48 on both sides, negative 48m on both sides. So our variable term is the same, but then our constant terms are different. We've got a 64 on the left and a 96 on the right. That means this is no solution. All right, we should be able to recognize those when we see them. All right, now into your favorite part, let's do some word problems where we have to set up some equations. I neglected to put a table on your slide somehow on this one, so sorry about that. You can just kind of, it's the identical table to the one that's on the next slide, the one next to it. So sorry for that, but you can just make some notes, make your own table. So here's how this works. Arabica coffee costs $28 per pound, so we fill in the coffee. Fill in the coffee table. 28 is the price of Arabica coffee, and Robusta coffee costs us $8.75 per pound. So $8.75 goes there. How many pounds of Arabica coffee must you mix with 3 pounds of Robusta? So 3 pounds of Robust, and we don't know how many pounds of Arabica coffee. They didn't tell us that. They're asking us that to make a blend that costs $15.50 per pound. So $15.50 is what we want here. So let's think about how this works. So Arabica coffee, I need 28, would be $28 per however many pounds that is. And then Robusta coffee is $8.75 times 3. And that comes out to 26. Not bad. Making marks that don't help. 26.25. And we need a combination of the two weights for our coffee blend. So we don't know what to multiply the 1550 by. So to figure out our total cost. So we need to know the total pounds of Arabica coffee plus the 3 pounds of Robusta coffee. And that is gonna give us what we want, 15.5 times A plus 3, okay? All right, and so we want total cost is what we want. So this is the column that matters to us. So to find that number, we just need to take the total of that column. So 28A plus 26.25, that's $28 per pound of Arabica coffee plus $26.25, which is what 3 pounds of the Robusta coffee would cost. And it's gonna equal $15.50 for the blend times that total pounds of coffee. Now we just gotta solve it. So it's 28A plus 26.25 equals 15.5A. All I'm doing is distributing here. So 15.5 times A plus 46.5. 15.5 times 3 is 46.5. Now I can solve. So subtract 15.5A from both sides. Subtract 26.25 from both sides. And that comes out, 28 minus 15.5 is 12.5A. And where did I go? 46.5 minus 26.25 is 20.25. Now we just divide 12.5, 12.5. And if you take your calculator, oh, I've already put it in the calculator there. I tried it out once. So 20.5 or 20.25 divided by 12.5 comes out to be $1.62. Or sorry, 1.62 pounds. So 1.62 is the amount of Arabica coffee that we need to make or use in our blend. So 1.62 pounds of Arabica coffee. It's kind of a weird problem. There's a lot to it. Good news is, now that you've seen this written down, pause the video here and see if you can work through the next one with this information. I will go ahead and work through the next one in just a second. In fact, I'm going to do it now, but pause your video and see if you can fill out the table and get the answer on your own. All right, so if you have come back now, you should have a 28 here and an A here, just like in the last problem. 8.75, that's an 8, believe it or not. 8.75 and a 5 goes here. And then a 12 goes here because that's the cost of the blend that we want. And then A plus 5 goes here. All right. So this again is 28.5 A. No, not 28.5. My bad. I'm sorry. Can't read my own handwriting. 28A is what that is. And then 8.75 times 5 is 43.75. And then this one is 12 times A plus 5. So set it up just like the last one, 28A plus 43.75 equals 12 times A plus 5. distribute the 12, 28A plus 43.75 equals 12A plus 60. Subtract 12A from both sides. Subtract 43.75. And you get 16A equals 16.25. Divide by 16. So this time, 16.25 divided by 16 is 1.01562. Okay, we don't want that whole number, so we're going to round it and say A is approximately 1.02 pounds of coffee, pounds of Arabica coffee. And in case you're wondering, I do not know why LB is the abbreviation for pound. I think maybe it has something to do with the Latin that our English language is based on. But 1.02 LB means pounds. All right. Hopefully you got that one figured out. All right, let's move on. We've got 2 more slides before the wrap up. Both about music services. So Cameron pays 95 cents per song with his current music service. A new music download service charges 89 cents per song with a $12 joining fee. Should Cameron switch to the new service? Well, we just need to set up an equation and ask Cameron a simple question. So his current music service is 0.95 per song. And we just need to set it up equal to the new music service, which is 0.89 per song plus the $12 fee. Let's solve that equation and see what happens. Subtract 0.89x. That would be 0.06x equals 12. Divide by 0.06. And x equals 200. So, think about what that means. 200 what? $200? 200 songs. So 200 songs. So if Cameron buys 200 or more songs, then it would be cheaper to switch to the new service. 200 songs, let's just run the numbers here. 200 times 0.89 plus 12 means that he's going to spend $190 on songs. So if he's going to buy $190 worth of songs, which would be 200 songs, then he should switch music services. All right. Last slide, last question here. Cameron pays, same setup, $95 per song. Cameron's friend tells him of another service that has a $15 fee, but charges 80 cents per song, so quite a bit cheaper per song. So let's do it again. In fact, you could pause and run it yourself. 0.95x equals 0.80x plus 15. Subtract 0.80x. So that would be 0.15x equals 15. Divide by 0.15. So x equals 100. And this case, if he buys 100 or more songs, or more than 100 songs rather, it would be cheaper for him to switch to the new music service. If he's not gonna download that many songs, he should stay where he's at. Okay, last slide here is just the wrap up. Gives you a couple of examples. If you end up with, one side equal to each other, then that's an identity with infinite solutions. If you end up with the two sides not equal to each other, then that is no solution. Your assignment, I didn't write it out, I'll put it here. Your assignment is 1-3 additional practice, and that is in EasyBridge, which is the online textbook. Should be 10 problems, guys, 10 problems to solve. I know you don't have a ton of time left in class, but work on those 10 problems. We will spend Monday on this as well. We're gonna do a lot of equation solving practice, guys. We've got to be pros at this. So 1-3 additional practice on EasyBridge, which is the online textbook. All right, have a great weekend. See you on Monday.